Hello and welcome. In today's first lab video, we'll be covering the topic of constant velocity. What exactly is constant velocity? Well, constant velocity is when an object must have constant speed in a constant direction. To look at constant velocity mathematically, we have to look at Newton's second law and two very specific equations. One key aspect of constant velocity is that there is no net force acting on an object. How is this possible? Well, this is possible due to Newton's first law of motion, which states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Mathematically, this works because when you plug in F net as 0, we see that the velocity final is the same as the velocity initial. Using our second equation, we can take the velocity that we have and predict the future position of the object from an initial position that we have observed. These two equations will help us when we are building the model that we will use to compare to the observed results that we will have from Tracker. For my observation, I took a plain skateboard and rolled it across a table and filmed what happened. Just observing the video, we can see that the skateboard rolled across the table with what seems to be constant velocity. Taking the recording, I placed it into Tracker to analyze the data that we have acquired through our video. First, I calibrated Tracker by giving it a known length, which was the length from one wheel to the other wheel. Next, I took the axis and placed it at the center of the front wheel and made that the origin. As the skateboard rolled across the table, I placed data points in the center of the wheel to record the position as the skateboard rolled by. What if the axes were flipped for our observation? Now, if that would happen, the skateboard would now be moving in the negative x direction, and all our plot points that are positive would now become negative. Looking at our Tracker data, we can use that data to find a velocity for the skateboard. Taking the first 2 points, which are r1 and rf, we find and plug it into our equation of velocity, we find that the velocity of the skateboard ended up to be 0.64 meters per second. Using the two equations that we learned about in the beginning of the video, we can create a model that will predict the position of the skateboard over a certain interval of time. From the two initial conditions that we found, the initial position as well as the velocity, we can plug that into our model, and as we can see, the model creates a true and straight graph. Taking the Tracker data that we acquired as well as the model predictions, we plot both of the points onto one chart. The blue line, which represents the data from the model, is straight and signifies constant velocity. The model assumes that there are no net forces acting upon the object and that the only thing that the object is doing is moving towards the positive x direction. The orange points on the graph represent the Tracker data that we acquired from the video. It seems that the Tracker data is slightly under the model representation of what the skateboard is supposed to do. Unlike a model, we do not live in a perfect world. There are still outside forces acting upon the skateboard as it rolls along the table, such as friction and drag, which are slowing down the skateboard, which is an indication of why the plot points are under the model data. This can be explained using Newton's first law of motion. Since friction is acting upon the skateboard in the opposite direction of its movement, there is a net force to the negative x direction, which slows down the skateboard eventually, causing the velocity to not be constant. To conclude, we have observed Newton's second law as well as Newton's first law in a test of constant velocity as we observed the skateboard rolling across the table. Overall, constant velocity happens when there is no net force, but that is impossible to happen in the real world since there are always forces acting upon an object such as air resistance and friction and drag. But from the lab data that we have acquired, it seems that it is very close to being possible to a model prediction.